OCR, the atom and models, is the very first thing that we need to know about on the spec. And that's seen over here. And also if we look before that, it also says that this section builds directly from GCSE Science. That means there'll be a few things in this section that we may already know about. You may remember this little drawing, which is a drawing of the structure of an atom. This is an electron, this is a nucleus, and in this nucleus we have protons and neutrons. Now we have the names of the key subatomic particles, we need to know a couple features of them, such as the relative mass and the relative charge. Electrons have a relative mass of 1 over 2000. Protons have a relative mass of 1, while neutrons also have a relative mass of 1. We also need to know the relative charge of these subatomic particles. Electrons have a relative charge of 1 minus. Protons have a relative charge of 1 plus, while neutrons have a relative charge of 0, because they are neutral. On the periodic table, we have a bunch of different elements, and we also need to know what these numbers are. For example, in carbon, the 6 represents the atomic number, which is the number of protons. The 12 represents the mass number, and this is just the number of neutrons and protons. The mass number on the periodic table is an average of different isotopes. What is an isotope? This is one of the key definitions that we need to know. An isotope is atoms of the same element with the same number of protons but different number of neutrons, which means it has a different mass number. Isotopes have the same chemical properties, and this is due to the same electron configuration, but they have different physical properties due to the different masses they have. Just in case you're wondering, this sign just means electrons. Now we know all of this about atoms. What is an atom? An atom is the smallest particle of chemical element that can exist. Now we're going to look at atomic models. There are 4 key models that you need to know about. The first model is Dalton's model, and this is the billiard ball model. Dalton believed that atoms were solid spheres and indivisible. Next, we need to know about Thomson's plum pudding model. Thomson carried out a series of experiments and found that atoms were not solid spheres or indivisible. He claimed that the atomic structure had to be charged, and his model showed a positively charged sphere with negative electrons stuck in it. The third person we need to know about is Rutherford, and he developed the nuclear model. Rutherford carried out the famous gold foil experiment, where he fired positively charged alpha particles at a thin gold sheet. He did expect most of the alpha particles to be slightly deflected due to the positive charge, but what actually happened was that most alpha particles went straight through, but some were deflected backwards by 90 degrees. This led to the development of the nuclear model, where we have a cloud of electrons. This represents the large deflection and the atoms going straight through. And there was a small positively charged nucleus, but most of the atom was empty space. But this model was not perfect and some modifications needed to be made. Moseley found that the nuclear charge increased by 1 unit per atom, and this led to the development of the idea that there were protons in the nucleus. But the nucleus was still too heavy, and this led to the eventual discovery of neutrons by Chadwick. This model was great, but there was a lot of things wrong about it. For example, if electrons were actually in a cloud, this will mean that the atom will collapse eventually. So Bohr developed a new model. In his model, he believed that electrons only existed in orbitals, which are shells, and nowhere else in between, and each shell had a fixed energy, and the movement of electrons between these orbitals emitted or absorbed electromagnetic radiation, and the electromagnetic radiation had a fixed frequency. That is all for atoms and models.